Here in this video we're looking at Hooke's law. The extension of a spring is directly proportional to the stretching force applied. This is only true if the limit of proportionality of the spring is not exceeded. F is proportional to X. Here F is the force applied and X is the extension. The force constant of a spring, K, is the force needed to produce a unit extension. The value of K tells us how stiff the spring is, how easy it is to stretch. A stiff spring is hard to stretch. Hence, Hooke's law can be written F equals Kx. Question 1. A spring of spring constant 45 newtons per meter is used to pull a block along a smooth level surface at constant speed. This constant speed means that there's a resultant force of 0. The spring is observed to stretch 12.0 centimeters whilst applying this force. How much force is applied? F equals Kx. Write down the formula, substitute in. K is 45, X is 0.12. Notice that it's 0.12 because 12 is 12 centimeters, 12.0. So to convert to meters, you have to divide by 100, which gives you 0.12. So the answer is 54 newtons. 2. A 35 newton force is used to stretch a rubber band which has a spring constant of 450 newtons per meter. What is the extension of the band in centimeters? X equals F divided by K, that's rearranging this equation, equals 35 divided by 450. Because we've got 35 in newtons is fine, and the unit's fine there, and newtons per meter is fine for the unit there for K. This gives an answer of 0.078 meters, which is equal to 7.8 centimeters. 3. If an 8 kilogram mass is hung on the end of a spring, it is stretched to 0.78 meters as a result. What is the force constant of the spring? K equals F over X equals 8.0 times 9.81 divided by 0.78 equals 101 newtons per meter. During an experiment, a spring was stretched by applying a variety of forces until it broke and its extension was recorded. Plot a graph and use it to determine the spring constant and the elastic limit. So to plot the graph up, let's just zoom out so we can see the whole thing at once. So what we can see here is that, first of all, you need to choose a scale. This one's going up to 80, and we've got 5, 10, 15, 20, 25, 30, 35, 40 squares, so each little square can be worth 2 and it fits really nicely. And this way we have to fit in a scale. This is probably the best scale to use. You need to use at least half the width of the graph paper. And plot up your points using nice crosses, draw a straight line where it is a straight line, and then draw a nice smooth curve to fit through the lines, fit through the points. And then the elastic limit, you see, is where it starts to curve and it's no longer straight. So where the cursor is now is the elastic limit. And what we need to do then is use the straight line part of the curve to find what the spring constant is. Spring constant is equal to F divided by X. So we can say, if we just use this part, then it would be 19, we'd have a change of 19 here in X, or times 10 to the minus 2 would be 0.19, and going up to 30 here, they've done it to, here I've done it to 0.18, 30 divided by 0.18, which is pretty similar. So that gives 167 newtons per meter. So the elastic limit is 30 newtons.